Hi, I am Fizuli. The topic of my third year project is tracking with drones. It was supervised by Dr. Paul Nata. The principal purpose of this project is using drones as tracking machines, following the subject given its specific details. For the testing purposes, the red square subject was chosen. There are two main challenges. First one is the process of detecting the object from the drone's camera by using image processing techniques. And the second is controlling the drone's movement in such a way that it follows the target, doesn't crash into it, and has a way of searching and finding the subject back if it was lost out of the sight. The drone I am using for this project is the second generation of the Parrot AR drone. It's a quadrotor, which has four brushless motors attached to the crossing of its body. Here's the list of the technical specifications of the drone. The main features used in the development are the cameras. It has two cameras, forward and down facing, and they both shoot HD videos. The diagram describes the design of the application. As a first step, application connects to the drone's onboard Wi-Fi network. If successful, the drone starts sending its navigational data back to the system. The system uses two APIs, the Drone Controlling API, called CV Drone, and Image Processing Library, OpenCV. The application asks CV Drone to get the video feed, then uses OpenCV to process the stream and detect the object of the interest. Once the location of the object in the video is identified, the application starts calculating the movement velocities for the drone. To calculate the velocities, PID, which stands for Proportional Integral Derivative Feedback System, is used. After calculation, the CV drone is used again to communicate with the drone and send movement commands. And now I want to demonstrate how the final tracking system works in the practice. For the demonstration, I attached a red square paper to the backlit of the notebook on which the application is running. As I move the laptop, the drone is detecting the movement and starts following. The window in the right bottom, which is divided into two screens, shows what the drone sees on the left side, and it put the green rectangle box around the target. On the right hand side, it's the processed binary stream after thresholding. It denoted everything that's not the target as black and the target itself as white. So let's see it in the action. Here, the drone came too close to the target. It realized it and moved a bit back. Afterwards, I'll intentionally move closer to the drone to demonstrate how it behaves in that situation. I moved too quick on purpose, so that the drone loses the target out of its sight. Now, the drone will be looking around until it finally finds the target, and it will continue following. This is the end of the demonstration. Thank you for watching.